right, good afternoon, everyone. So Marla and I are going to talk to you today about an experience that we had last year when we were piloting our new tissue engineering lab course in our BME program, a cell and tissue engineering track at UMass Lowell. So the challenge that we wanted to look at was the challenge that one has when we're trying to transition students from a theoretical knowledge basis to actually using that theory and that knowledge in a hands-on application, particularly in lab courses that are really skill-based. So real quick, this lab is a junior-senior tissue engineering lab where students have little to no prior experience in cell or tissue culture. The initial lab sessions did focus on developing some of those skills, aseptic technique, cell growth and passaging basics, things like that. And then we transitioned more into experimental design type or more open-ended projects. So we wanted to explore or have the student explore the effect of substrate stiffness on cell morphology and proliferation. So we gave them background on fibroblast growth, on tissue culture, plastic versus collagen gels, and had them design an experiment using those 3T3 fibroblasts. So what happened? Well, we gave them that experience, that background. We gave the students an experimental protocol to grow those cells on collagen gels, and then ended up observing a variety of outcomes from this pretty well-defined process. So this is what we want to talk about today, is highlight how we can develop processes to bridge the gap between theory and practical execution, and think about how we can do that in an effective way that facilitates learning. So Marla is going to talk about how we leverage that opportunity to enhance student learning.
Thanks, Adam. So once the students had made their gels and seeded the fibroblasts on the different stiffnesses of collagen hydrogels, they weren't going to see their experiment for 5 days. So my job as the TA was to fix the cells over the weekend with the hopes of the students being able to do immunofluorescence in the upcoming week. However, when I went to fix the cells, I noticed a lot of unusual things happening with the gels. For example, one student's gels got sucked up into my pipette, so they weren't appropriately polymerized. In another case, the student group actually seeded their cells on the opposite end of the 96 well plate. Then they actually created their collagen hydrogels. So it was just cells in media. And I was just sort of laughing to myself thinking, wow, I really wish the students were here to kind of see this and think through what really happened. So Adam and I decided to change what we had planned for Monday. And instead, we presented these scenarios to the students as if they were experiencing them in the lab. And so you can see the slide on the left was the one of 3 of the scenarios that we exposed them to. And then the protocol for the class sort of pedagogical approach was to have the students do a silent write individually first, then in intentionally paired small groups, they would brainstorm ideas and then share out with the class what they thought happened to these collagen gels. And so the silent write is actually a really valued part of my teaching practice. It benefits students who have trauma in their background, multilingual learners, students with anxiety, to give them that extra time they really need to be able to connect with what we're asking them to do and then retrieve the information they need to be able to conduct the assignment. And then the intentional groupings paired students who were academically and sort of professional skills aligned, so that maybe an anxiety student was not paired with a student who was super confident and would kind of overtake the conversation. And so by the end of the class, we were able to get sort of possible examples of what have happened in these collagen gel puzzles. And I'll hand it back to Adam for our reflection.
So out of this, what we really wanted to emphasize was that, students coming into these lab classes really have a familiarity with recipe-based labs, and they have a tendency to follow steps mechanically. And even our more experienced students didn't really have a strong sense of mindfulness and attentiveness to how their skills are developing in these open-ended labs. So what we're really hoping that people will take away from this specific case study is to reframe this failure opportunity or failure in the experimental protocol as an opportunity for learning, which encourage the students to see this failure as a valuable learning experience and take a more practice-oriented, growth mindset-oriented approach. And kind of the major takeaway in the last few seconds here is we did change our plan for the next week to adapt to this exercise and to let it be evolve naturally and organically so that we could best serve our students. And that's what I would encourage all of you to do, is to try to meet the students where they are and adapt your teaching to facilitate that learning.